Hi, this is video number 3 on the playlist where we're working through the June 2018 series of higher papers for Edexcel. This particular is paper 1 in this playlist, and there will be paper 2 and paper 3 as well. So we stopped in the last video at question number 14. We're going to start again with question number 15. Please do have a go at each of these questions, stop the video and then compare your solutions. Okay, so this particular one is a little bit tricky. It's called the difference of two squares, and it's how that is manipulated to suit these sorts of calculations. So I've got factorise a squared minus b squared. Well, it's kind of working backwards, because what we mean by that is a plus b multiplied by a minus b, and that would give you the answer to this particular question for 1 mark. Okay, the more important application of this is the second part of the question, which is a 3 marker, and it says hence or otherwise simplifies fully this. Now you could simplify it by just working it through, and you probably could pick up a couple of marks by doing that. However, what they're saying is that we've got this value of a squared, which is this value at the top here, and we've got actually this value of b squared. Okay, so the first value of a squared is going to be x squared plus 4. So that's the value of a, and I'm going to square that. Okay. So then we've got the value of b, which is this x squared minus 2. So I've got minus, and I've got x squared minus 2. And again, I'm going to square that. And that all equals a plus b times a minus b. Okay, because we've said it's exactly the same. Okay, so let's now see if we can work this out in a way that kind of works for you. Okay, so I'm going to say that I've got 2 things I need to work out. I need to work out a plus b, and I need to work out a minus b. Okay, so the first thing is a plus b. Well, a is this one, and b is this one. Okay, so a is going to be x squared plus 4, and I'm going to add that to x squared minus 2. Okay, so it's going to be a little bit tricky, but if I remove the brackets, I'm going to get x squared plus x squared is going to be 2x squared. Okay, and then I've got plus 4, and because I've got a plus here, I don't have to worry about it too much, but I've got plus 4 minus 2, so plus and a minus together is going to be a minus, so 4 minus 2 is going to be plus 2. Okay, so I've got my value there of a plus b. Okay, my next little bit is I need to work out the value of a minus b. Okay, well, a minus b, I'm going to have a is x squared plus 4, and minus b is going to be minus x squared minus 2. Okay, so let's again have a look at this. Now this is going to be maybe a little bit simpler, possibly, because when I remove the brackets, I end up with x squared minus x squared. Okay, so hopefully you'll be able to see that actually those 2 terms disappear. And then I've got, so this is minus x squared, and then I've got plus 4, and I've got minus minus 2. Well, minus minus 2 means plus 2. So actually, these 2 terms, when I simplify them out, I'm going to get 6. Okay, so I'm now in a position where if I want to work out the 2 multiplied but together, I've got 2x squared plus 2 times 6. Okay, so remember now we're dealing with this. So we've got a plus b, which is this bit, and we've got a minus b, which is this bit. So when I multiply the 2 together, I'm going to get 6 times 2x squared plus 2. Okay, and this little bit is going to be a minus b, and this little bit is a plus b. Okay, so when I multiply that out, I'm going to get 6 times 2x squared is 12x squared, and 6 times plus 2 is going to be plus 12. And actually, that's the answer to the question. Now, I could, if I want to, write this as a factorised term. So I've got x squared plus 1 like that. That will give me the answer to this question. So I don't know how people will take to that particular question. It is a bit tricky. You just need to be very careful when you work through it. But hopefully you've been able to follow my logic and the way that I've put things together. Okay, I hope it's been all right for you. Okay, let's move on then to a probability question, which is question number 16. It says there's only red counters, blue and purple counters. The ratio number of red counters to blue counters is 3 to 17. So what it means then is that the red counters are 3 out of 20. Okay, there's 20 counters altogether, 17 of them are blue and 3 of them are red. So the number of red, or the probability of red, is 3 out of 20. Okay, hopefully that's all right. It also said the probability that the counter is purple is 0.2. So that means, and again, they've just been a little bit careful, a bit tricky to sort of give you a fraction and then give you a decimal, but that decimal is equivalent to 1/5. Okay, so the probability that the counter of purple is 1/5. Well, that also means then that if the purple counters are 1/5, then red and blue must be the remainder, which is 4/5. Okay, so there must be 4/5 red and blue counters within the bag of counters. Okay, then it says work out the probability that Sam takes a red counter. Well, we know that 3/20 is the probability of him picking a red counter if there's just red and blue. So therefore, the probability must be 3/20, if I put probability, okay, must be 3/20 of the red and blue counters, which is 4/5. Okay, so remember we're working here in probabilities, we're not working in absolute amounts. We could be, but I don't think so. I think we need to work just in probabilities and be comfortable working through with fractions. Okay, so the probability when we calculate that out is going to be 3 times 4 is 12 and 2 times 5 is 100. So that's going to be 12% or 0.12, and that would be the answer to this particular question. So it does require a bit of thinking through. I have seen some of these questions in other papers, a very similar sort of questions. So maybe as you're doing your revision and as you're working through past papers, hopefully you'll come across some similar type of questions to have a look at. Okay, so let's have a look then at question number 17, which is a little bit easier. It's actually an algebraic fraction, and they just want you to simplify it. I do come across these from time to time. I think people are a bit more comfortable sometimes working through some of these sorts of things. So hopefully you'll have a technique or a method for doing this. What I would do is I need to factorise the top. Okay, so I usually say 3 times minus 3 is going to be minus 9, okay? I need two factors that when I add them together are going to make minus 8. So when I multiply them together, it makes minus 9, which is going to be minus 9 and plus 1. Okay, and when I add them together, I'm going to get minus 8 because minus 9 plus 1 is minus 8. Okay, again, if you're not sure about this, please do have a look at some of the playlists on factorising algebra fractions, and this will give you a lot more examples. Okay, so I've got now the ability to write the top line as 3x squared minus 9x plus 1x minus 3. And remember that if I simplified that, minus 9x plus 1x is going to be minus 8x. Okay, so that's fine because I haven't really changed anything. I've just written it in a slightly different way. The bottom, well, at the moment I'm going to factorise for 2x because I know then I'm going to get x minus 3. Now if I do that, I'm sort of sure that I'm going to be able to do something with the top, and I think with a lot of these things it is all about just having a little bit of a feel for it and just making sure that you're kind of thinking ahead a little bit. Okay, so the technique for the top bit is to factorise the first two terms. Now if I factorise the two terms for 3x, what I get is, guess what? X minus 3. Okay, well that's really helpful for me, okay? Because I know then that I can factorise the second two terms also by 1, and I get also x minus 3, okay? And then at the bottom I've still got this 2x x minus 3. Okay, now because these two bracketed terms are similar or the same as each other, I can bring them together and I can write the top as 3x plus 1, so 3x plus 1, and that's multiplied by x minus 3, okay, because those two terms are the same for both of these, okay? So I can bring those two together and then I can divide by 2x x minus 3. Okay, now that's the technique I use. I'm very aware that there are different ways that people might factorise this top bit, but that kind of works for me. So please do have a look at the playlist if you're not sure, or maybe have a go at your own way of doing this and see if you get the same answer. What I can do now is I can just divide top and bottom through by x minus 3, and my simplified solution is going to be 3x plus 1 on the top and 2x on the bottom, and that actually will be the answer to this particular question. Okay, hopefully that's all right for you. Please do have a look at the playlist as I've mentioned before if you're not sure. Okay, so let's move on then to question number 18. I think this is one where it's kind of hit or miss really. You know, you might get marks for this if you remember that actually if you're going to draw the grid of sine of x degrees minus 2, it just means all the values are 2 lower because we're minusing 2. Okay, so if we're minus 2, we started at 0 here, we're going to get minus 2. Okay, we started at minus 1 here, so we're going to get minus 3. We started at 0 here, so again minus 2. Okay, and minus 2 there and minus 2 down there. Okay, and when I draw all of this together, I'm going to get this very nice kind of curvy line. Okay, I'm sure again you'll do a better job than me, but it'll look something like that, and that will give you your full 2 marks. Okay, so now we're going to move on to, towards the end of the paper now, a 5 marker. Now there's actually only 2 questions left in this particular paper, so hopefully we'll be able to deal with both of them in this video, and we're on about 13 minutes at the moment. So the point P has coordinates 3, 4, point Q has coordinates A, B. Okay, a line perpendicular to, oh right, okay. So let's just have a look at what that looks like, okay. So the point P has coordinates 3, 4. Okay, well let's just have a look at that. All right, so here's my graph. Okay, and I'm going to draw 3, 4. Okay, and that's 3, and that's 4. Okay, and that's point P. Okay, and it's got it's a line PQ, isn't it? Okay, so it's going to look something, and I don't know quite what this is going to look like, but I'm going to go something like that. So that's the line PQ, okay? And it says point Q has coordinates A, B. Okay, well, I don't know where those coordinates are, okay, but I don't know. I'm just going to take a guess that somewhere it's either up here. So this could be point Q, or it could be down there. That could be point Q. It doesn't really matter to me, okay? But what I'm trying to do is I'm trying to get in my mind what this thing is looking like, okay? Then it says a line perpendicular, so at 90 degrees to PQ, is given by the equation 3x plus 2y equals 7. So again, they've just made it a little bit more tricky for me, okay? But what I need to do is look at that line and see if I can actually draw it on the graph. So I need to make this in the form y equals mx plus c. Okay, and this is going to be a line that's perpendicular, so I've got to make y the subject. So what I'm going to do is I'm going to take this 3x over here, and I'm going to get 2y equals minus 3x plus 7. Okay, that's fine, no problems at all. Okay, so I'll divide through by 2 now, and I'm going to get y is minus 3 over 2x plus 7 over 2. Okay. Okay, so okay. Yeah, so that's okay. All righty. Because the bit that's important to me is that this bit is because this is the perpendicular line. So this is perpendicular. Okay. Now, if it's perpendicular, it is the negative reciprocal, okay, of this particular line in terms of the gradient. Okay, so if I'm looking at line PQ, so line PQ, what I do know now is that rather than being something that goes kind of like this along here, which is this line, so this is y equals minus 3 over 2x plus 3.5, okay, this particular line here, I'm actually looking at this line now, which I know is at 90 degrees, and because it's at 90 degrees it means that the gradient is the negative reciprocal. So if I want to write the line PQ as y equals mx plus c, rather than writing minus 3 over 2, which is the perpendicular, I need to write that as positive 2 over 3. So the negative reciprocal, and minus times minus is a plus, okay, and that's going to be 2 over 3x plus c. Now what I'm going to be doing is at the moment I need to find the equation of line PQ, because I've got the gradient and actually I've also been given point P, which is the coordinates of a point that lies on this particular line. So I can just plug that in. I can say 4 is 2 over 3 times 3 plus c. So I'm using these coordinates at the top here, okay? And when I work that out, I'm actually going to get 4 equals 2 plus c. So c must equal 2. All right, so at long last I'm in a position where I can write the equation of line PQ is going to be y equals the same gradient, 2/3 x, and rather than plus c, I can write that as plus 2. So actually this line here that I drew is sort of accurate. It's not particularly good on the video, but it's sort of accurate. It's going to give you this line that goes through plus 2 as the y-intercept. Okay, so if I want to now answer this particular question, find the expression for b in terms of a, well, in terms of ab, so in terms of a b, so remember that b is the y coordinate and a is the x coordinate, so I can just simply plug that in. I can write this as b equals 2/3 of a plus 2, and that is actually the answer to this particular question. So we are towards the end of this paper here. Things are getting a little bit more complex, but I hope that's been useful to you. There are, I think, some similar questions on a playlist. I'm not entirely sure. If I can find it, I'll put a link through on this particular video so you'll be able to follow it through. It is always more difficult when they put things like the coordinate is AB, but you've got to remember that A is the value of X and B is the value of Y. Okay, so let's move on then finally to question number 20, which is n is an integer. So what we mean by that is n is a whole number, such that 3n plus 2 is less than or equal to 14 and 6n over n squared plus 5 is greater than 1. Okay, find all the possible values of n. All right, so what I think I'll do is I'm going to look at firstly the first expression here. Okay, so I've got 3n plus 2 is less than or equal to 14. So I can write that as 3n is less than or equal to 12, because if I minus the 2 from both sides, it then gives me 3n is less than or equal to 12. And if I divide through by 3, I get n is less than or equal to 4. Okay, so that's fine for me. The second bit of it is this thing here, okay, where we've got 6n over n squared plus 5 is greater than 1. All right, I think the way I would probably do that is I'd write that as 6n over n squared plus 5 is greater than 1 over 1, okay? Because 1 over 1 is the same as 1, but it gives me the idea or the ability then to be able to cross multiply through. And if I cross multiply through, I get 6n is greater than n squared plus 5. Okay, so I'm now in a position where I can take that value and I can just factorize it, because if I make this equal to 0, I've got n squared minus 6n plus 5. Okay, so what I've done there is I've taken this 6n, pulled it over to the other side, and I've written it in the form of a quadratic. Okay, I can then factorize that, and I can say 0 is greater than n minus 5 multiplied by n minus 1. Okay, so minus 5 times minus 1 is plus 5, and minus 5 minus 1 when added together will give you minus 6. Okay, so what we need to do now is put all of this together, and I've got a couple of things. I've got basically a quadratic equation, okay, and this is the roots of the quadratic, and also I've got this value of n which is less than or equal to 4. Okay, so if I drew a sketch of this quadratic, what I'm going to have is something like this. Now, bearing in mind, this means then that the roots are going to be plus 5 and plus 1. Because if I make that equal to 0, n minus 5 equals 0, so therefore n must be 5. Okay. And n must be 1. So what I've got here is a quadratic that goes like this. Okay. All right, now again, it's only a little bit of a sketch here. Okay, so at this point, my values, my integer values, my whole values are somewhere between 1 and 5. Okay, they are greater than 0, or sorry, less than 0. So it's actually all these values along here. So it's that one which is 2, that one that's 3, that one that's 4, and that one and that one. Okay. However, we've also got to bear in mind that we're being told that the values of n are less than or equal to 4. So if I just kind of draw that in here, this is where n equals 4. So we're in a position now where we can say that the values are going to be 4 because it equals 4. So n is 4. We're also going to say that the values could be 3. Or the values could be 2. But because of this boundary here, they can't be 1, and they certainly can't be 5, because 5 is greater than. So it can't include 1, but it does include 2, 3, and 4. So therefore, the values of n equal 2, 3, or 4. Okay, so again, a little bit tricky. These final couple of questions are quite difficult on this particular paper, but I hope you've been okay with that. I'm not sure that there are too many practice questions on this, but you could have a look at dealing with inequalities with quadratic equations, and see if you can find some material on that. I hope the whole series of videos has been useful to you. Please do add a comment below, subscribe to the channel. I'm going to be also videoing paper 2 and paper 3. Hopefully it'll be a good time for you to do a little bit of revision for your GCSEs, and I'll look forward to seeing you inside the next video.